From here to here is the same distance as from here to here. They're the same distance apart. If this is x, this is x. Whereas here, this distance to this distance, we'll call that y, is the same distance as from here to here. That is y. So again, a reflection, you're reflecting it, it's the same distance away, opposite side. So, of course, in math world, we have to kind of make this a little bit more trickier and involve numbers and formulas. So you might want to make sure you're writing these rules down. You don't have to copy every single thing down, not the coordinate plane, not the words, but I would focus on the rules and focus on what they are. You know, do you have to memorize these? Yes, but you may not have to memorize them because if they make sense to you, then there's no need to even necessarily memorize them. But I think you're going to find that you will memorize them over time just because we use them so much. All right, so here is our original point, and that is point P, and it is at 2, 3. P prime, that's how we call it, P with the little hash mark next to it, it's called P prime, is at 2, -3. So we are reflecting across the x-axis, and this is the x-axis right here. And so the idea is that if this point is 3 above the x-axis, when we reflect it across the x-axis, it's now going to be 3 below the x-axis. So that's what a reflection is. They are now equal distance from the line of reflection. But again, like I said, to make this in math world a little bit different, if you notice, the x's did not change. What changed is the sign of the y. So the way we note that is this is the way we write that rule, that x comma y, the x stays the same. So notice there's nothing here with the x, but the y changes signs. So if the y was negative, it's going to become positive. If the y is positive, it becomes negative. So this negative in front of the y is just a way of noting that it changes signs. All right, so now let's look at a reflection over the y-axis. And so this, ooh, that was terrible. This is a not straight line, but that's the y-axis right here. And so again, if the original point P at 2, 3 is 2 away from the line of reflection. When we reflect it, P prime is also going to be 2 away from the line of reflection. So kind of trying to figure out what that rule here is. Notice that that the x's changed sign. 2 became -2, and that the y did not change at all. 3 remained 3. So the way we note that in rule form is x comma y is going to be -x comma y. So by the negative x, I just mean that it changes signs. All right, now we have reflection over the line y equals x. This is the line y equals x, and it may help you if I say y equals 1x plus 0. That's the same thing as y equals x, okay? So the tricky part here with y equals x is that it's not as obvious. Like you can't just count and say, oh, well, that's about 1, and that's about 2, and that's about 2.5, and so this is about 1, this is about 2, that's about 2.5. It's still the same distance. It's just not easy to count like it was back here and back here. Those are easy to count because they're nice, clean points. You can count exactly where they are. Well, here it's not so easy to count. So still the same idea, still the same distance away from the line of reflection. But we're going to use a rule here to make it obvious for us, or to make it easier for us, I guess I should say. So x comma y becomes y comma x. And what that means is you are swapping the sign. So if P was at -3, 2, P prime is at 2, -3, because we are swapping the x and the y. And this is how we're noting that right here. We're swapping the x and the y. All right, and the last one that is a rule for you to remember is reflecting over the line y equals -x. And again, this is the same thing as saying y equals -1x plus 0, if that helps you kind of see the equation of the line and where I'm getting that from. So again, the rule is just that you swap them and you swap the sign. So not only are you swapping them, you're also swapping the sign. So y equals x, we swapped them, but now with this negative, we're also going to change their sign. So 3, 2, when you swap it, becomes 2, 3, but then you have to change their signs. So you get -2, -3. All right, so let's do a couple of examples. You should have this paper in front of you right now. There's 6 coordinate planes on the front. We're going to walk through. We're going to do them all together. And the idea is that for all 6 of these problems, you have a graph. A is at 1, 8. B is at 3, 2, and C is at 6, 4. And if at any time this video needs to be paused, because if I'm talking too fast, feel free to pause it so that you can fill in the coordinate plane and then start it again or rewind it, whatever you need to do, okay? So it says to reflect the triangle over the y-axis. And so if we go back and we look at our rules, the rule was to just change the sign of the x and keep the y. Okay, so we're going to change the sign of the x and keep the y. So x, y, we change the sign of the x and we keep the y. So a prime becomes -1, 8. We changed the sign of the x, we kept the y. B prime, change the sign of the x, keep the y. C prime, change the sign of the x, keep the y. And so now I'm going to go ahead and I'm going to graph them. So A prime is at -1, 8. And we label that A prime. B prime is at -3, 2. And then C prime is at -6, 1, 2, 3, 4. And that is C prime. And so here we go. And it should look like this. And you double check and make sure this is the y-axis. Does it look like it's a reflection over the y-axis? Or, this is 1 point away here, so it should be 1 point away there. This is 3 away here, so it should be 3 away here. This is 1, 2, 3, 4, 5, 6 this way, so it should be 1, 2, 3, 4, 5, 6 that way. And so it is. It is a reflection over the y-axis. All right, looking at the second example, reflection over the x-axis. The rule for reflecting over the x-axis is that your x stays the same. Yes. And that your y changes signs. All right, so A prime, my x stays the same, but my y changes signs. So I'm going to have 1, -8. B prime, my x stays the same, but my y changes signs. And for C prime, my x stays the same and my y changes signs. So now I'm going to go ahead and graph this. So I have 1, -8. So this is A prime. B prime, we have 3, -2. And then C prime, we have 6, -4. All right, and so then again, got my points. And then again, just to double check, here is a reflection over the x-axis. Everything should be the same distance away. This is 2, this is 2, this is 4, this is 4, this is 8, and this is 8. So I've shown that everything is equal distance away from the line of reflection. All right, number 3, reflecting over the line y equals x. And this is the line y equals x, I hope. I can't see very well. It's pretty close, okay? And so the rule for reflecting over the line y equals x is that xy becomes y, x. You're just swapping your x and your y. So A prime is 8, 1. B prime is 2 comma 3, and C prime is 4 comma 6. All right, so let's graph them. So A prime is 8 comma 1. B prime is 2 comma 3. And C prime is 4 comma 6. And I meant to change colors. And there you go. And so again, just to kind of show you, you can see A here is about the same as A there. I know that's not really pretty looking, but you get the idea. B here and B here. That's how it should be. Ha ha ha, B. C here and C here, and those match up as well. So there you go. You have a reflection over the line y is equal to x. All right, and so then next, number 4, we have a reflection over the line y equals negative x. So the rule here is if you have x comma y, that not only do you swap your x and your y, but you also change their sign. And so this is the line, I'm going to do my best to draw it. This is the line y equals negative x, okay? And so A prime, I swap my x and my y, and I change their sign. B prime, I swap my x and my y, and I change their sign. C prime, I swap my x and my y, and I change their sign. So -8, -1, B prime, -2, and -3, and C prime, all right, and so again, just because you can kind of see, I didn't make that line very long, did I? Probably should have gone a little bit more. But you can see that B is just as far apart here as it is here. Same thing. C is about here as it is here. And then A is here and it is here. So make sure everything's kind of equal distance from each other. Do a little quick check, all right? All right, so now we're going to reflect over a line that's not an axis or y equals x or y equals negative x. We're going to reflect over the line y is equal to 2. All right, so here is the line y equals 2. And so there is no formula that you can do. All you're going to be doing here on these examples is you're just going to be counting. And so B is already right here, so guess what? B prime is right there as well. Since C is 2 above here, it's going to be 2 below on the other side. So this is where C prime is going to be. And then A is 1, 2, 3, 4, 5, 6 above. So that means it's going to be 6 below. I'm going to start here. So 1, 2, 3, 4, 5, 6. And so then this is A prime. And there's no need for me to even sit here and count because I just counted and I saw. But it should be symmetrical. You know, you should be able, if I could turn the screen for you so that you could see, it should be symmetrical on that blue line of reflection or line of symmetry, which we'll talk about later. And the last example is over the line x is equal to -2. And here is where x equals -2. I think one of the ways people mess up here is that they mix up where x is and y is, okay? So this is your x-axis, this is your y-axis. So these are all your y numbers, these are all your x numbers. So don't let that mix you up too much, okay? All right, so we're reflecting over the line x equals -2. So again, this is 1, 2, 3 away here. So it's going to be 1, 2, 3 away on this side. So that's A prime. This is 1, 2, 3, 4, 5, 6, 7, 8 away here. So I'm going to go 8 away here. That's C prime. And then this is 1, 2, 3, 4, 5 here. So 4, 5 here. And that is B prime. And so then I want to connect my dots. And again, this one's a little bit easier to see than the other one, but it should be where if I could actually fold it on that blue line, they would match up. They're mirror images of each other. All right, so again, I hope this helps. Remember, you can send me a message through Remind, or you can email me at mathteachercoffee@gmail.com, and I will do my best to get back to you if you have any questions about this, okay? All right, good luck.